So with that, what I want to do is hop into a graphic that I have that will help you better conceptualize this explicit and this continuation structure. So let me go to my PowerPoint, and I know that I'm kind of bypassing the practice homework and the homework, okay? And if we want to go back to those when we wrap the rest of this up, I'm happy to do that. I just want to make sure that I can get to the things we need to get to tonight as well, okay? So let me go to my PowerPoint. So we're going to talk about, by the way, we're going to talk about some sources of return on capital and growth. We're going to talk about both endogenous and exogenous factors. We're going to talk about returns to scale, and we're going to talk about forecasting performance. That's where most of our time will ultimately be spent tonight. But before I get there, let me use this graphic for you. Make sure you can see this very well. So I want you to think about visualizing that on a timeline, this issue of time. And I will say that we're starting right now at moment zero. And I say it's moment zero because zero time has elapsed from right now to right now. Okay? It is literally that simple. Now, normally I think of these in years, so I can say zero time when in fact a nanosecond or 2 seconds or something did lapse, right? I mean, Michael Allen's sitting there saying, Rick, you don't have to count time. My second hand keeps moving. But in terms of years, not so much, right, Michael? So the year or the period after year zero is year one, and then year two, and then year three, and so on. This is referred to as discrete time. And I can expressly or explicitly forecast revenues and expenses with some degree of accuracy for some amount of discrete time. And the period for which I have created that express or explicit forecast, very rigorous. I've gotten together with all my vice presidents and we've said, okay, Taylor, I want you to tell me what your company, part of the company's growth is going to be. Think about the customers, think about the economy. Kylie, you do the same thing. And we're going to come up with these numbers on our week-long corporate retreat on Mario's private island in the Bahamas. The reason that Mario has it is because he was employee number one after me, and his stock options made him a mega millionaire. Okay? Good for you, my friend. I like your island. I have a mountaintop in Switzerland. So Mario knows that we can forecast next year probably pretty accurately. Oh, we may not know pandemics. We may not know big external shocks. That's why we call them shocks, because we don't know them, right? But all else equal, we should be able to be relatively accurate about next year. A little bit less so maybe the year after. We still should have some handle, but the further we go out in time, the less accurate our express or explicit forecasts become. I tend to use, for example purposes for you, a 5-year period more than anything else to cause you to have to repeat the same action over and over again, because I know repetition is what cements it in your brain, okay? In practicality, I rarely use more than 3 years of forecasts because I know that after about 3 years, enough is changing in the world, my world, your world, etc., that my guesses become more wags than they do anything credible, right? And you remember what the term WAG stands for, right? Okay, I knew you would. So at a point, I can't keep doing that. I can't continue because I'm fooling myself. Even Diana knows I'm doing that. So at a point, I'm going to start to count time from the beginning again because I'm going to use a different rate of growth. It's not going to be dynamic anymore. It's not going to be based upon what Taylor and Kylie and Carol and Mario all got together and informed me of. It's going to be based upon some long-term, very nominal, vanilla pudding-like expectation of growth in our economy, which is probably not unlike the expectation for inflation. And it's going to be some long-term expected GDP change, which we know normally is around 2 to 3%. In some hotter years, it's been 4, maybe 5, but longer term, we have a pretty good pattern set at 2 to 3% for the domestic economy. And I know that I'm going to start this the year after my explicit period. So I'm going to say the year after my 5-year explicit period, which you might think of in discrete time as year 6. The year after that, I'm starting over again at year 1. So at the end of 5, I kind of start to count. This is like a quintessent system, not a binomial system of 1 and 2, or 0 and 1, but a quintessent system where we count up to 5 and then we start counting over again. Count to 5, start counting over again. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay? Well, we're used to infinite systems. We never count over again. But in fact, we do for some purposes. Well, if I have discrete year 6 as being the year after my explicit period ends, I call that continuation year 1 because I'm continuing now. Continuation year 1, which I think of as a terminal period or continuation period. And what always comes before 1? 0. This becomes important because the Gordon growth model gives us a value at time 0 equal to the cash flow at time 1 divided by R minus G. So if I have used the Gordon growth model to forecast the value of all of my possible future cash flows on into forever, then it gives me a value that's as of the year that it all started. Not the first year, but the year it all started, times 0. So it's a present value. The Gordon growth model gives me a present value of year 0. And I've now got to discount it back to today. How much of that makes sense? How can I help you with this?
I think, I don't know, I don't want to speak for everybody else, but I feel like on the surface that makes sense. I personally just still don't get present value at all, and like what it means to me. Like I get you've got a growth rate, you've got a discount rate, and they're the opposite, and I don't understand what present value even means to me.
Okay.
And I mean, this makes sense from a forecasting standpoint because it's just a matter of risk and information, right? So you're just saying, okay, after 5 years, or like you said in your case, more practically speaking, you would say 3 because things change in the world, the market changes, inflation, all kinds of different things. So you're using a model that allows you to have a threshold for your accuracy because there's a certain threshold.
I have you stop for a minute. I'm not disagreeing with what you're saying. I want to give you another simple structure for present value that maybe will connect it for you. And then Michael Schwartz, since you said you think you understand my time structure here, I want you to explain it to us. Because one of the things I know is when somebody else explains it, and I do think that Michael understands it because he and I have talked about this. When somebody else explains it in different terms, it might be the terms that actually can make it sink in for someone that doesn't understand it. But let me come back, and Kylie, I'm going to use you for a minute. And I simply want you to think and observe, Matt. Okay? So you're going to have to come off mute, Kylie. I promise not to abuse you. If I give you $100 today, is it worth $100?
Today it is.
Yeah, I'll give you a nice, crisp, clean $100 bill, not a forgery. You could take it to a bank, and they would give you, 101s, or you take it to a grocery store, they'll give you $100 worth of groceries, whatever, right? If I said, I'm going to give you the $100, Kylie, I promise, but I'm not going to give it to you for 5 more years. So you can't have it today. I'm going to give it to you 5 years from now. Can you buy in 5 years with that $100 the same thing you can buy with it today?
No.
No. In fact, if we spend $100 in 5 years, we probably are getting what would cost us about $80 today, right?
Right.
Matt, the $80 is the present value of the $100 that we receive in the future. So think about that 100 as a cash flow. it's worth to you 100 when you get it, but not in today's dollars. And the difference is accounted for by some discounting. Does that help?
I don't know. I mean,
Okay.
when you use that example, it makes sense. But when we apply it to these models, like 4 or 5 years in the future, I don't get intuitively what does it mean to me?
Okay. We'll get there, I think. We'll play this game a couple of times. Okay. So, Mr. Schwartz, can you kind of run us through a recitation of our time signatures?
I mean, I think about it the same way you just sort of said it, but I also get confused in the models because I think present value and current value and future value gets confusing because there's a present value or there's like a future value of a present value and things like that.
Yeah.
That's sometimes easy to get wrapped around. I mean, in terms of this timeline, it makes sense because at year 5, your growth, or after your explicit period, your growth rate is changing, agreed upon change, or whatever you think it's going to be, right? So
Sure.
it can't be part of the same explicit evaluation, I guess. You can't apply the same equation to it. So it makes sense to have, and you need a year 0, which has to be when the end of your explicit period ends, because there has to be, a year is a spectrum, right? It's a 0 to 1. It's not just 1. It's not a point in time. So there has to be a 0 to, like 5 ends and 0 to 1 begins. So that's how I think about it. But I agree with Matt. I still absolutely, I have to think about it. Like present value of $100 is $100, but it's the present value of what $100 in 5 years would be is what sometimes I forget to think about it that way. And that's what helps, like your example with Kylie.
Well, I get the basic premise that money in the future is always going to be, a different value or will always be. I mean, I don't know. My understanding is money is always worth more today than what it is in the future because what you can do with it. So I get that it's going to change, but like you said, Michael, like this whole concept of it's a present value in the future, I don't know. I can't wrap my mind around it.
So start from that premise, and then we must move off of this. Start from that premise that money is worth more today than it is in the future. So in order for you to get $100 worth of value out of $100 today, all I've got to do is give you $100, right? But for you to get $100 of today's value out of something given to you in the future, it would have to be more than $100. It might have to be $120. In which case, we discount it back to the present. Not back to the future, back to the present. So $120 in the future may be the equivalent of $100 today, and that would be its present value based upon having discounted it. We'll play this game a few times. I promise you.
Can I ask one question just for clarification on this timeline?
Yes.
So basically we assign a growth rate from 0 through 4, and then we say it's too far out for us to realistically assign a growth rate. So we're going to go with something very basic that matches the economy, and we're going to start that at period 5. And then do we look at that as we're going to use that growth rate in perpetuity from then forward? Is that kind of like the thought process behind it, or is that why that becomes 0 times 0 is because that's times 0 of that growth being used forevermore?
That's exactly right, Mandy.
Okay.
Because we're going to bring into play the Gordon growth model at the point that we can no longer credibly assert a growth rate that is dynamic. We're going to just boil this down to something very vanilla pudding, very dull and boring. Economic growth.
I didn't really understand the discount rate until I sort of thought about it. Like it's essentially what ties the values together.
Yes.
You have to get from A to B or B to A, and you have to use. That's what the discount rate is. That helps. That's what helps me a lot.
Good.
It's very confusing.
Okay, so let me now take you to the next structure here, And I want you to think about this explicit and continuation structure. So, and these are numbers that are not coincidental to you. You know these numbers now. You've been playing with them in some respect for the last few days, although maybe I've got some different outcomes. So I have, in this case, I have expressly or explicitly forecasted my cash flows. You know that to get to this 1.95 number, that I started at 1.77 and I expanded it at 10%. And then 1.95 was again expanded at 10% to get to 2.14. Again at 10%, again at 10%, again at 10%. But now as I go beyond my explicit period and move into my continuation, I'm going to expand that which I was expanding at 10%. I'm now going to expand at my very ho-hum, dull growth rate of 2.5% in this case. These are the same numbers that you have at play in your in the Excel assignment. And you see then that I discount each of those numbers. And you see then that I have a running total of those discounted numbers. All that's happening here. This number is critical. This is my number in period 1 of continuation time, which I use in the numerator of my Gordon growth equation, and I interact it through a quotient of R minus G so that I get a continuing value that expresses the value at that moment in time of all future cash flows. And when is that moment in time? Well, the equation says it's at year 0. And year 0, when this is year 1, year 0 is the prior year. So year 0 is the last year of the explicit period that we have counted up through discrete time. Year 1 is whenever the next year is. And I tend to use, for example purposes, 5 years, but this could have as easily been 2 years, 3 years, 8 years, although that stretches the bounds of credibility, but it could have been, right? Any question?
So I've got a question. Just looking at this chart. So in year 5, the future cash flow will be 2.85.
That, in fact, we're about to show you how we come about that, Mike.
Okay.
But yes, I've sat down with all the best minds I could gather together, and we believe the free cash flow is going to be spinning out of our company in year 5 is 2.85.
So 135, which is the present value of the future cash flow, is in fact what, if that's what it would be worth now.
Yeah, in fact, based upon this discount rate, we're suggesting that 2.85 in 2024 would buy me the same thing that 1.35 would buy me today.
Gotcha. Yeah.
I have a question. Are we trying to forecast here for 4 years or for 5 years?
Well, we forecast for 5 years, knowing that our base year, the year for which we have all accumulated knowledge that's accurate, is 2019. So we're forecasting 20, 21, 22, 23, and 24, so 5 years. We then are effectively, Diana, forecasting one more year, right? But we're doing it knowing that it's just a little ballpark, very safe bet.